In this video, I want to talk a little bit more specifically about tools in ArcGIS Pro that one would use for analysis of raster data. Now, I want to pause here and explain something that ArcGIS Pro or previous ESRI software kind of has two separate tools to work with raster data. There are some built-in basic raster operations, data managing the data, clipping it, resizing it, resampling it, and so on. And there's also a specific extension or add-on for doing analysis of raster data. So if, some places they only work with vector data, they don't really do much with raster, and maybe they don't need to pay extra for this special analysis tool, but we have it available, and it is probably the most commonly used. It is one of the most commonly used analysis add-ons for ArcGIS Pro, and it's called the Spatial Analyst. It can be a little bit confusing because when you're looking at Toolbox, there's stuff like spatial statistics. There are, it doesn't say raster analysis, it says Spatial Analyst, and it's just more historical. They probably wish they would have called it raster analysis. It would have been more easy to explain, but for historical reasons, it's called the Spatial Analyst extension, and it has its own toolbox. So we'll talk a little bit about both. So some basic operations include mosaicing, where you can combine raster data sets together, mosaic them into a larger data set. Ortho mapping, which is kind of more specifically about aerial photography or remote sensing. You can manage your raster data sets, pre-process it for use in GIS, and get information about the raster. And within the spatial analyst tools, they come in different categories, and they have also some specialized tools as well. There's what's called conditional, which it's better to see an example for some of these, where you can use some type of logic to see if the things are true or false about the raster to create a new raster. Density, about how dense features are within, like get the density of points and create a raster of point density. The distance tools, those create either straight line or cost weighted distance. Extraction, which extract some of your raster into a new raster. Okay, we can kind of play this like a little game. So we talked in the last video, in the last part of the lecture, we talked a little bit about different types of operations: distance, local, neighborhood, or zonal. And just to kind of make it a little fun here, here's a spatial question. What areas of my project area have elevations between 50 and 100 feet above sea level? And that would be, so really what you're doing is you're taking a raster set and trying to identify something numerically about that data that's there, not about its neighbors, not about zones, doesn't really have anything to do with distance. That would be a local operation. So that would be like the example for reclassification, where we had different elevations, and then we reclassified those as either above, like below sea level, or above sea level. Spatial question: how far are each of my study sites from a river or a lake? Any guesses? Shouldn't be too, that one's should be kind of a softball. That'd be, how far is a distance operation. So here, these are points, and then this is a raster of distance to these features. So if you had either like a vector feature of rivers and lakes, you can create a raster that is, the numbers represent the distance from those water features. Okay, I have a raster layer of slope, so of elevation slope. I want to change this to an average slope over a 1 mile wide circular area. So you want to take a circular area and get the average within that circular area and kind of smooth out that elevation or slope information. What would work for that? Well, that would be a neighborhood operation where you have, for each cell, it takes a circular area of 1 mile and then gets the average of the cells within that neighborhood. Spatial question: what is the highest elevation in each county in California? Okay, so those counties can be zones. Then you can use an elevation data set and a county data set, do a zonal operation so that each county is classified, you can calculate the zones, which in this case would be counties. What is some statistic, maximum, minimum, and so on for each of those? And just talking about the ArcGIS Spatial Analyst, the analysis toolbox is various tools. There's various local functions, which would be per cell on the raster, conditional, logical, map algebra, math of different types, overlay, reclass, distances and neighborhood and zonal, distance, neighborhood, zonal, density, segmentation and classification. Let's talk a little bit about these. Density is about creating a raster of the density of vector objects. So let's say you have a bunch of points and you want to calculate the density of those points. That can be turned into a raster where the raster values, the high numbers are where it's most dense and the low numbers are where it's least dense. The same can be done with other types of geometry as well. Segmentation and classification are more specifically remote sensing like functions to classify features from images. This would fall into the more advanced analysis. These are kind of included to include some very basic remote sensing like functionality into the Spatial Analyst toolbox. And some of these are also available in other add-ons as well. They actually have new add-ons for actually working with aerial imagery that include some of the same tools. There's some general tools like extraction, generalization, and raster creation. So extraction, like you can say extract by mask is a tool that lets you take a polygon, a vector polygon, and then extract out a raster layer from that polygon. You could also clip it by a certain rectangular shape. Generalization, you can clean up or reduce detail in a raster, make it less noisy, smooth out the data. And raster creation, like you can make a new raster that's all ones or random values. And then there's special purpose tools, such as some raster tools specifically for working with groundwater, some that are specifically for doing studies of hydrology for surface water, some that are specific to studying, doing calculations for solar radiation, and some which are actually one of the most common ones are for types of surface analysis. So elevation related tools, of these, the surface one is one of the most commonly used. So I haven't actually used these, don't know too much about it, but these are some examples that are of things that are in the groundwater tools. And you probably won't need to be a groundwater hydrologist to really kind of get this, but if if that's your jam, then there are some tools for you. I'm not going to speak on it because I don't know anything that much about it. Hydrology, though, we've in physical geography, we talk about stream orders and watersheds or drainage basins. These are tools to calculate that type of thing, like calculate stream order. So number one streams combined to make number two streams, and twos combined to make threes, and so on. So these are really about tools related to things related to drainage basins and the flow of water within those drainage basins. Surface analysis, specifically things like with elevation, you can derive information such as slope. So this is an elevation raster, and this is, you can calculate what is the slope for every cell based on the elevation information. You can also do aspect, or which direction is the, are these, southern facing features, or are they northern facing features? So it can take the elevation data and you can calculate aspect if it's, which direction are these cells facing. At one time, this is, I don't know if it's still true, but I know in the past, this is the most commonly used operation from this data, this spatial analyst, was something called hillshade, which is like, because it's super cool. And a lot of the background images that you use have this kind of built in already. And what this does is it takes an elevation data set and it creates a shaded relief image that has a 3D look to it. You can also do things like a view shed, where you might have for different, let's say for observers, you can calculate, well, what can you see from here? And using the elevation, it says you can know like what is visible and not visible based on the elevation. So if you're in a kind of in a bowl, you can only see so far. If you're on top of the hill, you can see a lot farther, and so on. So this is just some examples of the variety of tools in ArcGIS Pro for analyzing and working with raster data. Thank you for watching.